Hi, and welcome to this tutorial about how energy forms can be converted. So, which of the following examples has the greatest thermal internal energy? Well, what's a measure of the internal energy, guys? What would it be? Think about it, think about it, think about it. Okay. 5 kilograms of water with a temperature of 150 degrees C, 8 kilograms of water with a temperature of 110 degrees C, 10 kilograms of water with a temperature of 90 degrees C, or 100 kilograms of water with a temperature of 28 degrees C. Now, I know all of you are like, oh, I know this. This isn't that hard. Think again. Because you guys might be going towards the first one, 5 kilograms of water at 150 degrees C, but that's actually not the correct answer. The correct answer is D, because you have more mass or more amount of water, and it's harder for it to have that temperature of 28 degrees C. So the greatest thermal energy is 100 kilograms of water at 28 degrees C. A toy car with the initial kinetic energy rolls to a stop along a flat track. Because of friction, some kinetic energy was transferred to A, thermal energy. Well, think about friction. I want you to take your hands, rub them together. What happens? They get hot. Oh, friction has thermal energy. When you have friction, you're going to transfer some of your kinetic energy to thermal energy. A ball was initially dropped from a height of 4 meters. After the ball bounces, it returns to a height of only 2 meters. How much of the ball's initial gravitational potential energy was transformed between the initial position and the final position? Well, guys, we have half the height, so we have half the total energy. There you go. Aluminum was once used as wires in home construction. Recently, it was changed to copper wires. Which of the following statements best explains why aluminum was replaced for copper? Well, I hope you would note that aluminum is a little bit cheaper than copper, so if we're replacing it, it's for a good reason. It's probably a safety reason or to increase efficiency. So, A, when electrical energy was passed through copper wire, less of the energy removes copper atoms from the wire. Okay, guys, they're not going to be removing copper atoms. Electrical energy from copper wire the electrical energy that a copper wire can transfer is less than aluminum wire. Guys, why would you be using something that's less? Okay.
Smile, Mom.
As a byproduct of transmission, more electrical energy is transformed to wasted thermal energy to aluminum wire than copper. And that makes sense that would be the answer. Why would we be eliminating aluminum wire? Because we have wasted thermal, which is a potential fire risk. Okay? After a student stretches a rubber band many times, they notice the rubber band is now very warm to the touch. Which of the following predictions can be made? Okay? We're thinking we're stretching a rubber band. Everybody's stretching that rubber band in their mind. The rubber band collected heat from the surrounding. No, that doesn't even make sense to me, honestly, guys. It wouldn't have collected. The stretching transferred energy to the rubber band, and some of the energy was transferred to heating the rubber band. That actually makes sense, because if I'm stretching, I'm transferring energy, and some of that could become heat energy. Okay? The chemical reactions, was there any chemical reactions going on? No, there wasn't. The rubber band must have been warm. Does it say it was warm? No. When I stretch the rubber band, I'm transferring energy to the rubber band, and some of that energy is transferred to the heating of the rubber band. That's what's going on. Energy is created as a result of which activity? Well, can energy be created? This is kind of a trick question, because you might think, well, if they're asking me then this, then it must be created, and I must have learned something wrong. No, energy cannot be created. It can only be transformed. It can only change forms. When a match is initially struck, some amount of chemical energy is transferred to, is it A, thermal energy? Yeah, what's a match? It's hot. I know a match can burn my little fingers. I burn them many times. Okay, the diagram below is a representation of a person skiing down a hill with a potential energy and kinetic energies noted. Use the diagram to answer the following question. Which statement best summarizes the energy represented? Okay. Well, look, we have 50,000 joules here. We have 50,000 when you add them together, 50,000 and then 50,000. The total mechanical energy is not 100,000 because it's transferring back and forth between kinetic energy and potential energy. It's 50,000. It's always going to be 50,000. We don't lose energy. We don't gain energy. We transform it. We transform some of it to kinetic and then back to potential. The figure below is a model of the electromagnetic spectrum. Use the diagram to answer the following question. Which of the following statements would be true if an increase in photon quantum energy has occurred? Well, if I have an increase in energy, I'm not going to have a wavelength increasing. And direction doesn't matter. Wave speed, not so much. What definitely has to be true is the frequency has to have increased. If I have an increase in energy, I have to have an increase in frequency in a wavelength. When a piece of wood is burning, the stored energy within the chemical bonds is being transferred into the gas, thus heating the surrounding energy? No. Is it just, yeah, it's just heating the surrounding energy. That's it. Okay? The stored energy is transferred into the heating of the surrounding areas, not energy. That's why we burn wood. So I hope this short tutorial helped you out. I hope you better understand that energy has forms that can be created. We have potential energy that can convert to kinetic energy, and we have kinetic energy that you can have it change to thermal energy. And then you also have radiant energy, which heats, it comes from the sun and makes pretty much everything. Thank you, William, for drawing very nice pictures on my thing today. And he's telling you to just smile. Mom. Okay, I guess I'll smile more. Apparently, I sound happier when I smile when I do the tutorials. Thanks, guys, and have a great one.